This is the Plastic Principle.
All right, everyone. Welcome to the Plastic Principle podcast. I am Dr. John Diaz, board certified plastic surgeon here in Beverly Hills. And this is a podcast about anything and everything to mold and improve your life. And so far, a lot of my episodes have been about plastic surgery procedures. But I've also addressed issues in terms of improving your own life and the changes you can make to empower yourself. And today I'm very, very excited to introduce this topic that I'm fascinated with, which is improving your quality of life long-term and anti-aging ideas. So I'm very excited to introduce my guest today, Dr. Mahshid Shelechi. She just completed her PhD at USC in the Department of Gerontology and is an expert on anti-aging with a specific kind of research interest with respect to cancer.
Yes.
And protecting against cancer. So I think we have a lot of things we can talk about today. So I'm very excited to have you on. Thank you for being here.
Thank you for inviting me.
Absolutely. So I think it'd be great for the audience listening to hear a little bit about your background, your training, what has led you into this interest area of research. And then I think I'd love to hear about your research and kind of like what you've learned in your studies in terms of anti-aging, how it relates to cancer and other areas as well. So why don't we begin? You said you did your undergraduate studies where?
I did my undergrad in Iran, back in Iran, my country.
Yes.
It was on food science and agriculture.
Right. Because you're also a dietitian.
And I'm also a dietitian.
Yes. So you're very, very equipped to talk about these topics because all of these are related. Diet, anti-aging, cancer, all of these things have to do with lifestyle and health.
Right, yes. Yeah. And then when I came to the United States, I got my master in nutrition. I was very interested in the diet because obesity, overweight, cancer rating going up, and it's rising both nationwide, specifically United States. And our lifespan is increasing. So our lifespan has been dramatically increased in the past 100 years. But our health span or our healthy life period has not equivalently increased.
I'm so happy you said that because this is a concept that I recently was introduced to. Is this, and I think it's very important for people to think about this, the difference between lifespan and health span.
Yes.
Because you can live very long.
Right.
I mean,
Exactly.
there are patients that live 90s and 100, but I can only speak from my own experience. When I was in the hospital as a resident, we would rotate through the hospice and other wards, and we would have patients in their 90s, but they were basically essentially comatose and not really functional and not conscious or aware of their surroundings. And so, you can argue that they're alive, but is that a healthy lifestyle? Most people will probably say they don't want to be in that situation or condition. No. So that's where health span comes in, or how long you can live in a healthy way that allows you to be functional.
Exactly.
Right.
Exactly. So like we have two people, they both live up to their, let's say 85 years old.
Yes.
But the one with a healthy lifespan, they are mobile, independent in their 80s, they're socially active, they have good eyesight, but vice versa, the other person, by the age of 40 to 60, they have high cholesterol, high sugar, high blood pressure. By 80s, their dementia, stroke, disabilities. So the goal is to increase our health span. So we're living in a good health.
Right.
And that's the goal, and that's a key. And that's a key for scientists right now, that they're studying aging in biological level, that how we can increase that health span.
Right.
Not necessarily increasing the lifespan. And so aging is a complex process.
Right.
But in CDC report, I was mentioning to you, I was reading the reports of CDC, and it was showing that population that they will live over 65 years old will be more than 22% by 2030.
Which is huge.
Which is huge. So we are living more than ever before. And but at the same time, 80% of population who are 65 years and older, they have at least one chronic condition. And when people develop that chronic condition, that's the end of their health span.
Yes.
And the top 5 chronic conditions, which is heart disease, the first, cancer, Alzheimer, diabetes. And these are all the result of aging. Basically, aging is a catalyst of all the diseases. So if we can understand how we age and we can optimize the pace and quality of aging, that can be one of the most important intervention that we can do to increase the health span.
Absolutely.
So that's what I studied during I was interested in to how we can prevent and delay age-related diseases. And during my master program in nutrition, I was a research assistant and on a study that we were looking at colorectal cancer with dark chocolate. So because I was doing
colorectal cancer with dark chocolate. I love this study. Did you get to eat the chocolate when you did that? Okay.
We're doing 70% gradually dark chocolate. And I remember that time like we were like making the diet for the mice. The diet was 10% dark chocolate in mice. And the mice had colon cancer. So under the microscope, I had to look at the number of cell proliferation, the number of the living cell compared to the number of the dead cells in dark chocolates fed mice compared to the control group. And fascinating because I was the one that was under the microscope looking at the number. So the number of the proliferative cancer cells significantly decreased in the mice that they were fed dark chocolate compared to the control. And over there, I was thinking, this is fascinating. Just with diet, no drug, no side effect, just with a simple dietary intervention, we can change, either prevent the diseases or delay the development and progression of the diseases. So I became interested in cancer and became interested in diet and dark chocolate. I started to eat dark chocolate. I was not a fan of dark chocolate.
I prefer milk chocolate myself or sweeter chocolate.
Because of the But that's interesting when you know the benefits of something, automatically you become interested and you start eating it and it becomes part of your lifestyle. And right now I cannot eat milk chocolate. Can you believe it? I cannot. Like for me, if it's not dark chocolate, I cannot touch. I don't enjoy it.
Right,
because you know, my palate, it's accustomed to dark chocolate. And I started with like 60% dark chocolate, then 70%. Right now, I cannot eat less than 85% dark chocolate.
And for anyone listening, because I've tried different percentages, it gets extremely bitter
as you get higher. Less sugar.
Right. So it's not as tasty for the average person.
Yes.
But that, you know, I think it's incredibly important, the link between diet and health span and cancer. They're extremely highly linked. And I would like to go back and hear more about this study, but I want you to continue kind of sharing your path to your PhD.
Yes. So then I decided that, okay, I have this knowledge. Why not I share it with the people that I love and also the population? Then I decided to get my dietitian degree. I had to go like 1 year extra with my master, take extra classes. I did my dietary internship at VA Hospital in LA, Los Angeles. And I wanted to have impact in the life of the people. But at the same time, I was really interested in research. I was really interested to find out what's the underlying between all the diseases, how we can better understand aging. And that's where I joined Dr. Walter Longo's lab in gerontology department at USC.
So you worked at your PhD is at the Department of Gerontology at USC.
Yes.
Yeah, that's a very well-respected program.
It is.
Very prestigious.
It's actually one of the few aging programs in the US.
Yes.
And at first, I started to work on a clinical trial in breast cancer and prostate cancer, which we look at the effect of fasting mimicking diets. So it's a type of fasting, and I can talk about it more in details about fasting and why it's beneficial. But that's how I got involved in human clinical trial that we started to do at USC with breast cancer and prostate cancer patients. And then clinical trial, I started to get involved with more like oncologists, working in oncologists, started to get interested in prostate cancer and breast cancer. And when I started my PhD, because my PhD is in biology of aging, I had to look at the model organism to find out the mechanism that prove the mechanism.
Yeah.
In a PhD program.
Yeah.
And we cannot do that in human.
Right.
For the
That's
ethical
why
reasons.
so many studies are done in rats and why.
In rats and mice.
And this is important because
Yeah.
sometimes, obviously when you have conclusions, you're extrapolating them to humans.
Right.
But there's always that caveat that you have to say, we can't completely correlate.
Exactly.
It's a correlation.
It is.
It's not conclusive,
Yeah.
and then human studies are needed. Right?
Exactly,
Yeah.
exactly. But that's a base.
Yeah,
that
that's
gives
the
us
basis, of course. Yeah.
That starts from unicellular yeast, then
Right.
flies, worms,
Right.
rats, monkeys,
Right.
and then in human.
Right.
So I started to, then my mentor, Dr. Longo, came to me and said, there are so many studies on breast cancer and fasting mimicking diet. And there are studies on mice and fasting mimicking diet, but not that much on prostate. There's no study on prostate and fasting mimicking and dietary intervention. Why not you focus on prostate cancer? And I was like, sure. This is very interesting because prostate cancer is second leading cause of death in male in the United States. So I was like, yes, I'll take over it. So I started to work in vitro cell culture
Right.
on prostate cancer cell lines, and also in mice with prostate cancer, which I injected them with tumor, like
Right.
cancer cell lines,
Right.
to develop tumors, and started to dietary intervention. But besides dietary intervention, I was interested to look at drugs. So prostate cancer, one of the first line therapies are hormone therapy for prostate cancer.
Yes.
But not for prostate cancer. For most of the cancer, the drug therapies fails after a couple of years because the tumor, they become resistant to the therapies. It's like chemotherapy or hormone therapy. And then the occurrence of the cancer happens. So I was interested to see if dietary intervention is combined with standard of care treatments, then can it increase the efficacy? And it has been proven in mice and other type of cancer that if in dietary intervention or starving, so we can go back to how dietary intervention works. Before I think that I'm
Giving me the big...
yes, but we need to talk about it more, that why it's important.
Yeah.
So let me backward it.
Well, let me ask you this question. What can you give us your specific PhD thesis, your dissertation? What was the topic?
So the topic was looking at a fasting mimicking diet and combined with hormone therapy and simvastatin on prostate cancer.
So looking at both hormone therapy, fasting regimens
Yes.
on the outcome of the cancer.
Yes.
What was the
decreasing
conclusion?
progression of the prostate cancer. So the conclusion is when fasting mimicking diets
Yes.
or fasting,
Right.
dietary intervention,
Right.
which I think I need to talk about it, why fasting works.
Yeah.
But should I talk about why fasting works then?
After you tell me that, yeah.
So I showed that when it is combined with hormone therapy, it shows that it can increase the efficacy
Yes.
of the hormonal therapy.
So it can help. It
can
enhances.
help and enhances it.
Right.
Exactly.
Right.
So in vitro, I showed that in so many different type of prostate cancer cell lines, because prostate cancer is very heterogeneous and has different stages.
Right.
From the stages, we call it castration-sensitive prostate cancer to castration-insensitive prostate cancer. So the both early stage prostate cancer and late stage prostate cancer, it showed that when fasting mimicking diet is combined with treatment, hormone therapy, it is more efficient to kill the prostate cancer cell lines compared to when the hormone therapy is by itself or fasting is by itself. And what I did during my PhD, part of my project was RNA sequencing. So we can talk about it that with computational biology and genetic testing nowadays, we understand better why aging happens. But for, again, back to my thesis, we looked at RNA, we did RNA sequencing in the prostate cancer cell lines with fasting and without fasting. So we looked at the genes that are upregulated with fasting and the genes that are downregulated, and also the pathways that involve those genes and what pathways are upregulated in cancer, prostate cancer cell lines.
Yeah.
So the goal was to look at the pathways that are upregulated and see what drugs can block those pathways. So one of those drugs was simvastatin.
Simvastatin.
Because one of the pathway that I showed that is upregulated in prostate cancer is cholesterol biosynthesis.
I was just going to say, that's interesting because simvastatin is a cholesterol drug.
Cholesterol
right.
drug.
Cholesterol lowering drug. Interesting.
Cholesterol lowering drug.
Right.
And there are studies recently that show simvastatin can help and be helpful in different type of cancers, such as lung cancer, colorectal cancer, head and neck cancer. So what the RNA-seq showed that cholesterol biosynthesis pathway is upregulated during fasting. So I decided to block that with simvastatin, and simvastatin is one of the most commonly type of cholesterol lowering drugs.
Very common. Yeah.
And it's safe in human. So it shows that simvastatin, when it's combined with fasting and combined with hormone therapy, which I looked at enzalutamide, there are different hormone therapies that it's approved by FDA for prostate cancer. One of them is enzalutamide. They're all combined together to significantly decrease the prostate cancer cell lines. That's
amazing.
That was, yes, very fascinating.
That's amazing.
We have clinical trial right now. Actually, we just finished the enrollment. We looked at the effect of fasting mimicking diet, which I explain in details later, in breast and prostate cancer patients at USC. So the goal was to look at the efficacy of dietary intervention during chemotherapy in both breast and prostate cancer, and to see if fasting can decrease the side effects of the chemotherapy. So why we were interested in that and why we looked at it?
Well, let me interrupt here because this subject, the first time I ever heard of fasting, and I think this is great for the audience to know, is the first scientist I heard about was Linus Pauling. Is this familiar? Have you heard of Linus Pauling?
No.
So in medical school, we learned about him. He was, I think this emerged in like the 70s perhaps, and he believed that a low-calorie diet, I think he saw in rats that are grown with a calorie-restricted diet, they tend to live longer than rats that do not. Yes. So he saw that, and then he started mimicking that diet for himself. So he was like a very undernourished scientist, but he strongly believed that this would lead to a longer life, and that was the first time I had heard of it. So can you share, kind of like maybe in a basic way, for the average non-scientist who's listening, why is it believed that fasting can lead to a longer life, perhaps? Yeah. And maybe link it to, obviously, it sounds like it's also helpful in cancer.
Yes. This is a perfect question, and I have a lot to say about that.
Can you say it in one? It's funny in media. It's like, can you say it in one sentence? But it's not. It's so complicated.
It is so. Yeah.
I struggle with this all the time because things in science, they're so complicated. Yeah. So when you were describing your research, I always think of like in medical school when we learn biochemistry. It's an enormous poster with so many lines connecting all these chemicals and molecules. Yeah. And it's like if you change one thing here, it changes the whole thing everywhere else. It's like the saying of like a butterfly, wing creates like a hurricane somewhere else on the earth. Because everything is so connected. And that's why it's so hard to know, is it the diet? Is this medication? Is it this? Is it that? Exactly. But what would be like maybe the most simple way you can explain how these things are linked?
Sure, yes. let me go talk about the history of fasting. I always tell people that during human evolution, fasting was part of our diet.
That's true.
During the hunter and gatherer, people would not eat for a long period of time.
Very true.
So our body accustomed to fasting and not eating for a long time. But nowadays, the food is available 24 hours. We can eat whatever we want, whenever, nighttime, during the day. So fasting, why fasting is very important and how can lead to longevity or longer lifespan that we see in mice. We see even in monkeys, it shows that they were in calorie restriction, they live longer and they had less cardiovascular disease and less cancer. The reason, a most simple way to say it, because during the fasting, you deprive the body from certain nutrients. That nutrient is glucose. That nutrient is amino acid. Amino acid is a building block of protein.
And glucose is the building block of sugar.
Sugar.
Yeah.
Glucose is sugar.
Yeah.
Exactly. And in the beginning, I said aging is a complex process.
Yes.
But it governs or is controlled by mechanisms and some pathways.
Right.
And the most important pathways are nutrient sensing pathways. We call it nutrient sensing pathways because they are the pathways that become activated by nutrients.
Yes.
So these pathways that there are pro-aging pathways, they're IGF-1 pathway, PKA pathway, and RAS pathway. So this pathway leads, they can accelerate aging. And again, these pathways are activated by certain nutrients. And those nutrients is glucose and certain type of amino acid, which mainly branch chain amino acid. So when we are fasting, we're depriving body from sugar and certain type of amino acids. So what happens, the cells, the normal cells, they go to the maintenance modes or protection modes. That means the energy, instead of consuming, burning to get the nutrient from the food, what they do, they shift it toward repair. So that shifting toward repair and maintenance helps the cells to stay healthier for a longer period of time. And I always say that these nutrient sensing pathways is kind of like a switch, and the food turns them on and off. So if you give them food, it turns them on, it accelerates aging. You turn it off, you shut it down, and put them in a protected mode. So cell decrease proliferation, or it decrease growth in cells. So this same concept is for cancer cells.
Right.
So what happens during the cancer cells, most of the cancer cells, they need nutrients. And the nutrient for cancer cells, the number one is glucose, and then amino acids from proteins. So what happens during fasting or calorie restriction is that the normal cells, they go to this protection mode because they reserve the energy. But the cancer cells, because of the mutation they have, they cannot go to that protection mode, and they keep replicating. Again, because of the mutation, they keep replicating.
Right.
But at the same time, during fasting, due to nutrient scarcity, they become weakened. And when we do chemotherapy or hormone therapy, immunotherapy, they better can target the cancer cells.
Because they're vulnerable.
Because they're vulnerable. But at the same time, the normal cells, they call it stress resistance. So they become resistant toward the effect of chemotherapy or hormone therapies.
The normal cells,
the normal
right? Because they're operating normally.
Because they're operating normally. But because they fasting induce stress resistance in normal cells, they become resistant toward the side effects of the cancer treatments. Because the side effects, it's come from normal cells right now.
Right.
So that's why in the clinical trials, we were looking at if chemotherapy and hormone therapy is combined with fasting or calorie restriction intervention, then can we see efficacy in the chemotherapy? But that means better targeting the cancer cell in both breast and prostate cancer cells.
This makes sense. This is a very interesting subject because this comes up all the time. Yeah. So let me address some things. I'm thinking of questions patients always ask me. Yeah. and family members, and if I'm at a party or I'm at a gathering, inevitably there are certain things people say. And I think that what you're saying right now will answer a lot of this. So one of the things people will say often is like, John, look at how many people have cancer now. It's like there's so much cancer happening. Yeah. And so one of the things that I say is, cancer is a byproduct of our longer lifespan.
Yes.
Because the longer we live, the longer our cells are dividing and working and doing all the machinery that they're doing.
And damage more.
And more damage. Yeah. Eventually, they break down. And cancer really, in the way I think of it, is cancer is a breakdown of the cell's normal function. The cells break down like anything. An analogy that one of my professors once said to me, and it stuck with me because I thought it kind of encapsulated well this idea. It's like a car.
Yeah.
So you buy a car, it's brand new, it's shiny,
That's
it works.
That's my mentor talking about.
Is that right?
So the same example as the car.
The same analogy.
Yes,
It works great because when you think of it, when we're human beings, when we're born and we're healthy, we're like a brand new shiny Ferrari.
Exactly.
Amazing machine.
Yeah. Amazing engine.
Amazing engine. Right. Works incredibly well, right? So if you run that Ferrari, which it's meant to do, you're running it, you're using it, you're driving it and driving it and driving it. Over time, like any mechanical machine, it's gonna break down. You might need to replace a part. You might need to replace this. So our body, in many ways, is the same. And so eventually, you have to replace parts.
Yep.
And if you have to maintain it as well, you have to add the oil. You have to change the tires. Yeah. Just the same way our human bodies are. We need to maintain them. We need to. Hopefully, the goal is that we don't have to replace our parts. But an interesting theory is that one day we'll have the technology to maybe replace some of the parts that we couldn't replace before.
Yes.
So I bring that up because you were saying about how we evolved as human beings. We were hunter-gatherers, and we did not have the abundance of food we have now. So our cells normally are not used to having this incredible abundance of food and nutrients
all the time,
which is like pumping like super high octane gasoline into your Ferrari. You're just burning that thing. You're just running that Ferrari full speed. It may break down sooner. It's kind of like this idea. So if the cell is slowing down when there's calorie restriction, you're kind of using our evolutionary background to we're kind of hacking it. So you're kind of making the cell shut down a little bit. Exactly. In the same way that maybe if you took that Ferrari and put it in the garage and covered it,
that's true, yeah.
You're going to keep that Ferrari more pristine. Right. Yeah. So that's maybe how this is related. It's an interesting way to think about it. So that's something a lot of people come to me and say, well, why is there so much cancer? And it's because we're living longer than ever. I mean, when you think of a point that I bring up is what I ask people, what do you think the average lifespan was in the 1800s? Do you know the number? Like
maybe 60? I
think it's 50s.
50s, yeah.
Yeah, I think if you lived to like in the early 1800s, if you lived to you were 50, that was great.
That was great, yeah.
Yeah, that was a great. So, but now people. But now, we're living.
It's not. If I was reading in a Time magazine, if a baby girl born today, the average life expectancy is 83 years.
That's incredible.
Girls, and for male is usually less. It's 78 years old.
That's incredible.
That's incredible.
Incredible.
But as you said, the more we age,
the more things can break down.
This break down, and the body cannot get rid of the tumor.
Right.
Or cancer cells.
Develops cancer.
And develop cancer.
Right.
The body cannot get rid of the sticky plaque in the brain. Alzheimer and dementia happens.
Right.
And
the other thing I bring up sometimes is if you really think about it, going back to I love that you brought up the evolution, like what we were evolutionarily designed to do. Because if you really think about it, human beings were evolutionarily designed to maybe start reproducing at age 13 or 14, right after puberty.
Yeah.
You have your first child, let's say at 13.
Yeah.
Now that child's 13, 14, ready to reproduce. You're 26, 27, 28, 30 maybe. Yeah. You're still strong to support your child, supporting their child. Yes. By the time back in those days, by the time you were 50, you were kind of useless because now your grandchild is having a child of their own.
Yes.
So
that's evolutionary theory that you're talking about.
Right, because we really, our bodies really were not truly designed
Yeah.
for the lifespan that we're seeing now.
Right.
And that's a really hard thing for people to kind of wrap their head around.
Yes.
We're living way beyond maybe our cells were designed to live.
Yes. Yeah.
It's kind of crazy.
Yeah. But the goal of the scientists and anti-aging research is that live by 110 and 120, but healthy 110 and 120.
That's right.
And it sounds that maybe it's unachievable, but we can do it.
I think
with the correct interventions and maintaining with the I think the computational biology that we have, genetic testing that we have nowadays. One day we can achieve that. And about like 30 to 40 years ago, aging was a biological myth. But now we are understanding what's happening, and we are starting to what's happening during aging and in biological level and how we can slow it down.
Right. And one of these areas, as your research has shown, is perhaps calorie restriction. So here's my question to you. I don't know. I've heard, like I said, I was introduced to this idea in medical school about calorie restriction and how studies are showing longer lifespan. I don't know if I would advocate for myself. I don't want to follow a calorie restriction diet. I don't want to follow that. But I do want to follow a very calorie balanced diet.
Yes.
So what's your opinion, given the research you've had? Would you extrapolate that and say, yes, we should all follow a calorie restricted diet? Or is it like maintaining a healthy weight and not exceeding your ideal body weight?
Good question. So there are different type of calorie restriction.
Okay.
There's a periodic fasting, alternative fasting, intermittent fasting,
Right.
time restricted feeding. These are all in the category of calorie restriction.
Yeah.
And water only fasting. And my focus is on fasting mimicking diet. So my mentor was working on with a group of oncologists at USC. They were looking at different type of cancer in patients with different type of cancer, lung cancer, colorectal cancer, breast cancer. And they were asking them to only do only water only fasting. That means
So
not
having
eating anything.
Just water.
For 48 to 72 hours.
Okay.
Patient who did more than 48 hours of water only fasting, they decreased significantly their side effects from chemotherapy, and they decreased DNA damage. But it's very hard to tell normal people to fast or not eat anything for 72 hours.
It's very
and just
unpleasant.
imagine for cancer patients. So it was very difficult. So what happened? My mentor, he developed this diet that's called fasting mimicking diet. So fasting mimicking diet, he tested first in mice to see if he sees the same result as complete fasting, which it decreases the IGF-1, decreases glucose, decreases inflammatory marker in the body. So basically fasting mimicking diet is a very low calorie diet that is plant-based. And it has certain ratio of amino acids. So based on the research that amino acid is not good for cancer, he created this diet that has certain type of ratio. So it's generally plant-based, low in protein, because protein is one of the
sources of amino acids.
Of amino acids that accelerate aging.
Yes.
And so it's very low calorie diet, and the patient gets some nourishment, so it's not complete fasting. That was the area of my research that I looked at in mice that was not complete water only fasting, which we saw the result the past 50 years. There are a lot of research that shows water only fasting. It's helpful, especially for decreasing the incidence of cancer. But again, it's not safe. It may cause malnourishment in patients.
Yes.
So I'm
At the
not...
end of the day, if we advocate something, you have to have compliance. Like people have to do
Exactly.
it.
And
if it's not pleasant, nobody's going to do it.
Nobody's going to do it. And if it's specifically if it's not safe, it's not under the supervision.
Right.
So that's why the fasting mimicking diet was diet that I focus on. Again, low calorie. We see the same result. It mimics a fasting, but body gets the nourishment. But also, I strongly believe in longevity diet. Longevity diet is a diet that as you mentioned, is balanced diet. It's very similar to Mediterranean diet. It's lower in red meat, lower generally in animal protein, higher in plant-based protein. It's higher in omega-3 fatty acids. So these are the, I think, key factors when people asking what kind of diet I need. Should I do calorie restriction? Yes, fasting is good. Again, needs to be under supervision. Fasting mimicking diet is something that really look at cellular level, that it can cause stem cell regeneration and immune cell rejuvenation in mice. And it's something that I always tell my patient, the purpose is not weight loss, the purpose is longevity. Because what happens during fasting, I mentioned, the cells goes to maintenance mode. But what happens during it's the results happening during refeeding. When we start eating, then we are generating it. We show this, that we generate new stem cells, new immune cells. So that the benefits, it's during the refeeding time after the fasting. But again, the diet that we see a great result is Mediterranean diets that people can maintain for a long period of time. And beyond that diet, something that can become part of the lifestyle. Because I never believe in drastic diet.
Yes, it never works.
Never works.
Right.
Super low carb diet or ketogenic diet.
Yes.
It fails.
Right.
All the study shows after 2 years, all those drastic cutting in certain type of nutrient, it fails.
That's right.
And to me, is not single macronutrient. It's the ratio of the macronutrient that is very important. The ratio of the carbohydrate to protein, like protein to fat, that all the ratio that makes it more important rather than single macronutrients.
The thing is, it's so interesting because everyone wants to be healthy. Everyone wants to lose weight. We can talk about the GLP-1, the medications that make you lose weight. But here's the issue. As you mentioned, the United States, most countries, they're obese.
Yeah.
The United States in particular. So most people in this country are so far down the spectrum on the other end of this curve of being obese, that if we were to say to them, now let's start having you follow a calorie, mimicking restricted diet, there's no way they're going to follow it. And so a lot of times when people have asked me in the past, like, what do I recommend? I recommend like something in moderation, because if we can just get most people to just be balanced, that alone is enormous. And what you were saying, the Mediterranean diet, that is a diet that potentially can be realistically followed. It's not drastic. People can still have enjoyable foods. And the idea of being low in animal meats and things like that, it's kind of, again, mimicking, talking about evolution. Evolutionarily, when we were hunter-gatherers, meat was like a luxury.
Right.
Most human beings didn't have access to a lot of meat.
Exactly.
So we were probably designed not to have as much meat as we have today. I mean, if you will look around, sometimes most people are having meat every single meal, or they're having some type of. It's probably excessive.
It's excessive, very excessive. Actually, if you look at centenarians,
Yes.
the people who live longest
Yes.
in the world, they call it blue zones. Those
Yes.
areas.
Yes.
Their diet is very high in plant-based protein, and very low in red meat. They eat red meat, but in their traditional celebrations,
Right.
it's happened like twice or 3 times per year.
Wow, that's very little.
That's very little, but mostly it's from legumes, nuts, fish. So those are the diets. Beside that, they are active and socially active, physically active. But when you look at the diet, it's very low in red meat and animal protein.
Yes.
So I think, and again, it's a ratio of those macronutrients that is very important.
Right.
And when they look at the calorie restricted diet, it was a study that they looked at calorie restriction, and then they looked at protein restriction. And actually it was protein restriction that significantly decreased all-cause mortality in patients less than 65 years old, because older adults, they need higher amount of protein.
Right.
And this study, it was huge. It was by Morgan Levine. It published in 2016 that when they controlled for the protein, it was the protein that led to, and when they controlled for the animal protein, the plant-based protein, it was not had any association with all-cause mortality. So the culprit was red meat, specifically processed red meat.
Is it possible? Because this is what I always think about. So, because when most people hear this, they immediately conclude and say, "Okay, it's animal protein is bad." Is it possible also it's because of if you have a diet that's high in animal protein, in general, you're going to have a diet that's higher in fat. The way the meat is prepared, fried, or with oil, saturated fat. Yeah. So what I would argue is, I don't know the study that you're referring to, but my guess is that you want to restrict the amount of animal protein you have, but you also want to have some, because to your point, you just said a major problem for people as they get older is a lack of protein.
Right.
And loss of muscle mass. Loss of muscle mass, exactly. Right. So that's why I always advocate something balanced. You have to have everything in moderation.
Right.
I think that's easier for people to follow, number one.
Exactly. Yeah.
And probably long term is maybe the most helpful.
Yes.
Moderation
and again, increasing the fish consumption.
Yes.
That's higher in omega-3 fatty acids.
Right.
And following, longevity diet that's it's more high in olive oil, nuts, healthy fats, complex carbohydrates,
right.
Not simple sugar.
Right.
Less juices. As one of the things that in American diet we can see is all this fast food and juice and
absolutely high sugar, very
intake.
Concentrated sugar. Yes. So now let me ask you, with the GLP-1, these are the medications like Ozempic and Mounjaro. Would you argue that we know the benefits for people with diabetes?
Yes.
But let's say this is for the average person listening. They might think like, oh my God, this is another reason for me to go on Ozempic and lose more weight because I'm going to increase my lifespan. What would you say to that person?
First of all, there is no study that shows the lifespan with GLP-1. And I don't want the people hate me if I say that because I know so many people.
Well, let's say it in the most diplomatic way possible, because I think I'm reading your mind. I think I know what you're going to say.
So for GLP-1, to be an effective dose, it needs to be a very high dose. And high dose of GLP-1, more clinical trial studies showing that can has negative effect on overall health. Long term. And we can go back and beside GLP-1, we can talk about other anti-aging drugs that the issue with them, there are not enough long-term evidence.
Right.
To show the benefit. And what happened with most of the drug, they come out and after years and years, the negative or side effects comes out, and all of a sudden FDA is like, oops, we have to take this drug away. It caused this and this and this.
The way I think about it, I go back to this poster in medical school, this huge poster of the biochemical pathways, and how if you change one thing in this corner, how it affects the whole other side of the poster on the other corner. And I think this is what I often tell patients. Like, I know these things sound so great, and they are. I mean, this has been an incredible discovery and an incredible benefit for so many patients, but there's never a substitute for a grounded diet regimen and exercise regimen. Anytime you intervene and you change the pathway, there's going to be, you got to give something up to get something. There's never a shortcut. Never a shortcut.
Our body works as a system.
Yes.
It's not individually your brain, your gut.
Right.
Every system, all of them, they work together.
Right.
You change your gut microbiota, you can decrease dementia and Alzheimer's disease. They all work together. It's like a system.
That's right.
And as you said, when you change, you cannot specifically change one thing because they're all connected together.
They're all connected. And it's going to have some side effects somewhere.
So, for example, let me tell you, there's a drug. I don't know if you heard about the rapamycin.
Yeah. Yes.
It's known for its anti-aging.
That's right.
It increased lifespan in mice by 40%.
That's right.
40% increased lifespan in mice. And also it increased healthy lifespan in mice as well. So great results in mice in lifespan. But what it does, basically rapamycin, I talk about nutrient sensing pathway. One of them is mTOR pathway.
Yes.
Mammalian target of rapamycin. So rapamycin blocks mTOR. We have two mTOR. We have mTOR1, we have mTOR2. mTOR1 is for longevity. mTOR2, it regulates glucose uptake, regulate insulin sensitivity. But what rapamycin does, it blocks both mTOR1 and mTOR2. So mTOR1, it blocks it, it causes longevity in mice. But studies showed in mice has high side effects, hyperglycemia, insulin insensitivity, so many side effects that even though in mice, they stopped at high doses because of the side effects.
Yes.
So why? Because it's not specific for mTOR1.
Right.
It shut down the whole pathway.
Right.
So it creates unwanted changes in metabolic pathways.
And
unexpected.
Right.
And it was in clinical trial. They stopped it in human. There are more clinical trial ongoing, but it's for all drugs.
Everything.
Most of the drugs
That's
that
right.
you cannot specify, and it's kind of not going back, but this is something new. This is gene editing.
Oh, yes. That's a whole new field.
That's a whole new field. Like you want to be specific, but if it's a little bit off target,
right. It can
cause cell malfunction.
Right. That's right. That's right. So it's extremely complicated.
So it's extremely complicated, but it's good. These are all discoveries
Yes.
that we are probably just starting them, and long term, it can be very beneficial. But right now, there is not enough long term evidence. And if we can change the whole system with dietary intervention, as we talked about, like low calorie diet, fasting mimicking diet, it downregulates mTOR pathway. But at the same time, because it decreases glucose uptake, it avoids hyperglycemia that rapamycin causes
Right.
it. Or there is another diet drug called pictilicips. It's a PI3 kinase inhibitor pathway. PI3 kinase, it's upregulated in most of cancer, specifically prostate cancer. And I was interested in PI3 kinase pathway in my research, and I looked at it specifically. So PI3 kinase pathway is another pathway, again, that it can be activated by diet. And diet activates, like increase IGF-1. IGF-1 upregulates this pathway. So this pathway can be blocked by a drug called pictilicipe, and oncology was using it until they saw a side effect in human, which was hyperglycemia. What does calorie restriction fasting mimicking diet? We showed it does. It downregulates this pathway, but at the same time, it decreases hyperglycemia. So then we give high dose of this drug to mice. The mice died from hyperglycemia. But when we combine it with fasting mimicking diet, they live. They didn't die.
Right.
Because it diminishes. So something that we can do the intervention with fasting with minimal side effects or nice side effects, and also with exercise.
Yes.
It's much more powerful
Right.
than drugs.
Right.
But sometimes combining the drugs with those interventions is more effective, such as like, again, in
Right.
cancer and chemotherapy and hormone therapy, that you need those standard of
Right.
care drugs.
Right.
But the combination of it might decrease the side effects of the drugs.
So I think anyone listening appreciates how complex this is.
Yes.
And I think if I were to maybe share like a take-home message, I would say the most important thing to understand is that for most Americans, for most people who are struggling, who are overweight, obese, the first step they can take to just start leading a lifestyle that's going to give them a longer lifespan is to start getting to a more normal weight with a more moderate diet. I mean, that is a simple first step toward a great path.
Yes.
Right? Because it's so easy and so enticing. People watch TV or they read, social media now especially, it's about clickbait. And everyone wants to just read, what's the berry that's going to make me live longer? What's the one food I have to, what's the superfood that I have to eat to make me live longer? But as you're explaining, it is so complicated. There is no magic bullet. It really does come down to moderation. But here is what I would say. The one thing that is very simple, I think, and straightforward, well, more simple and straightforward maybe, is the importance of exercise.
Yes.
And the reason I bring this up is because another concept that I heard that blew me away, and it was very relevant to me because I just turned 51. So I'm 51.
Congratulations.
I don't know if that's good to congratulate, but I appreciate it. But health is very important to me, and it's one of the reasons why I love plastic surgery, because it is all about trying to improve the human body. But here's what someone said, and it made an impact: is the idea that if you want to have a long health span, that is what you said, living longer without chronic disease, so you can enjoy your life, have a good quality of life. The person was asking, are you going to want to be able to walk up a flight of stairs when you're 70 or 75? You're like, of course. Yeah. Do you want to pick up your grandchildren when you're 75? Absolutely. Do you want to be able to play with your kids? Your kids' kid? Of course. Everyone says, of course. And when you think of being a grandparent, you're like, of course I'm going to do those things. And what he was saying is, okay, well, can you lift this much weight now when you're 50? And I forget what the number is, but when you start going through these questions, most people are not able to lift, let's say, a significant amount of weight when they're 50 and not able to do certain activities. Well, guess what? Your physical abilities only decrease over time. Declines. So if you want to be very functional at 75, that means that your trajectory, you should be in prime health at certain ages, because you're going to have an inevitable decline. Yeah. So the higher and the more physically able you are at each age, the less you're going to decline, and you're going to be able to reach those goals. And that is one of the things that has inspired me personally to really try to be as fit as possible, even though it gets harder. Yeah. But it's because of this idea that if you want to be functional at these ages, you need to be prime. You need to be in your prime physical shape at each decade. Yes. Yeah. Yes. What are your thoughts about exercise and how that fits into
I think exercise, second most after diet, it's the second most important intervention that it can increase health span.
Yes.
And the guideline for longevity, for physical activity, it's recommend walking fast for 1 hour every day, or swimming, biking, or running every other day, and 2 hours during the weekend. And I love swimming and biking because it's less stress on joints.
Right. Low impact exercise.
And it has, low impact exercise. And exercise have been shown amazing benefits for cognitive function, decrease inflammation in the body, and also tissue regeneration. So exercise, I think it's one of the most simple things that every single person should do daily, at least 30-minute walking. You can have a goal, pick your favorite coffee shop, just walk there 30 minutes and come back. Take the stairs instead of taking the elevator or escalator.
Yes.
We can do simple intervention or simple steps to keep our body physically active.
Yes.
And again, going back to centenarian, if you look at centenarians, they don't have sedentary lifestyle. They are either fishermen or they do farming. In Okinawa, which is one of the blue zones, is in Japan. They do some type of martial arts until 90 years old. They call it Tai Chi.
Yes.
So they're always keeping themselves active. And so again, exercise is very important. And there's so many studies showing the benefits of exercise on health span. And one of the studies actually was Australian studies. They looked at 204,000 individuals, male and female, and they followed them for 8 years. And the participants, and they were between 45 years to 75 years old. And the participant who did 150 minutes exercise, moderate to vigorous exercise per week, they live 45 to 50%. No, I'm sorry, not living. They have 45 to 50% decrease in all-cause mortality.
Wow.
compared to the participant who did not exercise.
That's amazing.
So it was amazing.
Yes.
That just like 150 minutes exercise per week, moderate to vigorous activity.
Yes.
So to me, that this is huge. This is something that it doesn't cost that much.
Right. It doesn't have to be. You don't.
Doesn't
like you said, just
it's
walking.
simple.
I know.
And again, no side effects. And with just doing that,
it's
you
so
can
important.
decrease the rate of diseases. Again, cancer, like prostate cancer is one of most of the patient of prostate cancer patient. When I would go to oncologist clinic, I would say I'm not joking, 7 to 80% of overweight.
Yes.
And they had type 2 diabetes.
Yes.
And
in fact, obesity, it's linked to every other chronic disease.
Actually,
every
yes.
disease.
Obesity and overweight is linked to prostate cancer.
Everything.
So, and
Everything.
I'm sure like to many other cancers.
And like you said, the cognitive decline, it's all linked.
Like, it's all linked together.
That's right.
And so yeah, just I think with simple things or doing simple intervention, people can incorporate exercise to their daily lifestyle.
Yeah, it's such an important idea and something that people overlook because delayed gratification. This idea of like doing things now so you can benefit in the future. Yeah. It's like a concept people hate.
Yeah.
It's like saving. It's like paying down your credit cards. It's not fun at all. No one wants to do the things that are not fun. But as you get older, it becomes so important to think about that because, as I said, this idea of you want to live long, but you want to be able to be functional.
Yeah.
And be able to do a simple thing like bending over and picking up an object, or like you said, being able to be self-sufficient and live on your own if you need to, or run an errand. I mean, and keeping that in mind, that the better physical condition you are in at each decade, the less decline you're going to have and the more you're going to be able to do at older decades.
Yeah. The muscle mass is another thing for older people is very important.
Lose it.
That's why like lifting weight or weightlifting, not too heavy, but like maintaining that muscle mass is very important because it's your muscle that supports the bone.
That's right.
And one of the high risk for older adults is falling,
fractures,
hip fracture.
Yes.
So if you have a strong muscle, it can protect the bone.
Right.
And so all of these are osteoporosis. Joint diseases. All these diseases easily can be preventable.
It's like you said, such a simple thing but so powerful.
Right.
So the last thing I want to address with you is what the future of anti-aging is. So we talked about nutrition, your expertise in that. We talked about exercise. An area that I think a lot of people are fascinated by is what you kind of alluded to with gene editing, and perhaps manipulating our genes, or maybe taking certain types of exogenous or artificial outside medications or drugs that could potentially change the metabolism of our cells or the errors in our cells. What are some of the things that you've heard in your department that are like pioneering, cutting edge, like futuristic things about anti-aging?
So for the future of anti-aging, as you said, like CRISPR, gene editing.
Right.
I think that's fascinating.
Yes.
So gene editing right now, so for people who don't know what is gene editing, so basically we can go, or scientists can go to DNA inside of the cells and cut the part of the DNA that it's damaged.
Right.
Or in diseases, it causes like rare genetic diseases.
Right. Or if someone has a gene that predisposes them to a chronic
certain conditions,
right? You can cut that out.
You can cut that out.
Yeah,
yes,
that's amazing.
And so that is again like fascinating and amazing that CRISPR is the type very powerful and most precise gene editing they call CRISPR.
Right.
That goes and it finds what sequence need to be cut, and they cut that part of DNA.
Right.
We are in beginning right now of gene editing with anti-aging. And in fact, gene editing or CRISPR is not being used in anti-aging yet because of the limitation it has. But it has been used for certain rare genetic disorders. And the limitation of gene editing right now, again, is one of the most challenging part is to be organ specific and cell type specific, to go and cut the specific part that scientists they're interested. Because if it's a tiny bit off target of that gene editing, it can cause cancer, it can cause cell malfunctioning. So it's something that I think it has a huge potential for the future, but right now it's not being used for anti-aging.
Right.
The same as telomeres gene therapy.
I was going to get to that because I think a lot, well, not a lot, but people in medicine, and especially medical students, we have heard that the length of the telomere is related to age.
Yeah, it's getting shorter.
It gets shorter and shorter and shorter.
Yeah.
And the cell has less and less ability to replicate normally.
Yeah.
So lengthening the telomeres has been an area of like some scientific research.
Yes. And in fact, there was some supplement that it came out. I forgot the name. But it's showed in mice that in normal mice that it can lengthen the short telomeres. But in human, not. And they started to advertising that in human, it can lengthen the telomeres. But again, there's no long-term or there's very weak evidence about that. But telomeres gene therapy is something else. The telomeres gene therapy in mice, it shows that it increased the lifespan and health span in mice by 13 to 24%. But in human, they're not again using it as anti-aging. It's being used for very rare genetic disorder. They have critically short telomeres that leads to pulmonary fibrosis because of the very short telomere. So for certain genetic disorder that have really short telomere, they use that telomeres gene therapy, but not for anti-aging yet. Yes, but that's again something that is promising for in the future.
Yes, very.
For normal, healthy individuals.
Right.
And there was one doctor at Bach Institute, Dr. Litgro, that he believes that one day we can have a vaccine, anti-aging vaccine. And it can happen, like the same thing that I said, like about 50 years ago when we were talking about anti-aging, people had no idea about biological level of what's going on in aging, but we have much better understanding nowadays, and I can see that with the technology that we have, everything is going very fast.
It's accelerating exponentially.
Yeah, exactly.
So how would the vaccine work? So the vaccine would inject you with something that would stimulate your...
So the goal is to slow down the aging, but as you said, aging, it's a complex.
It's so complicated.
Just like, it's not specific thing, but if it's something that vaccine can
stimulate one part or stop there, right?
Yeah. So like right now we see in mice that mutation in certain gene actually can cause long lifespan. In human, of course, because of ethical point, we cannot do that. But there are some genes that mutation, if happens, it can increase lifespan.
Interesting.
So it's something that's it can happen in the future.
Right. On paper, theoretically, these things are possible.
These things are possible. But for now, I would say the most powerful intervention, again, I think is nutrition.
Yes.
In both prevention and delaying the progress of the disease.
And the thing that most people can start doing today.
Yes.
Right?
Yes,
I mean, these are things you can start doing today.
Exactly.
And exercise.
And yeah.
I'll end with this because anyone that knows me knows I'm into these futuristic, tech things. So there's a guy named Ray Kurzweil, and he's known as a futurist, and he theorizes about a lot of things that are going to happen in the future. And he's been correct about many, many innovations in science. For example, predicting the power of computers, predicting the emergence of AI. And he's talked about this event that he refers to as the singularity. And the idea is that his idea of the future and anti-aging involves the a blending of human biological beings with scientific computer assistance.
Oh, yes, with computational biology.
Right.
Yes.
So he believes that's where we're heading.
Yes, totally. Absolutely. I believe in that.
And you believe in that too.
Yes.
And I mean, what we've seen with AI kind of almost, confirms that his theory at least has some solid ground, because we are heading in this direction. One of the things he said that I thought was fascinating, because as you mentioned, cancer is such a cause of early death or death. So one of the things he said, and that's why I was asking you about the vaccine, because he has this idea that perhaps in the future, we'll have every single type of cancer mapped in a way that we'll know exactly which proteins are expressed on the surface. And then we can inject nanomolecules that are basically nano computer chips on the scale of a nanometer, that we can inject, whatever it is, tens of thousands of these. Each one is designed to target a specific expression of proteins for a specific cancer. It will circulate around your body until that one cancer cell emerges, and it will attach and kill it at the one cell stage.
Yeah.
and that will prevent all cancer. And then if you're, obviously people have discussed, organ replacement. And so if your organ fails, you get a new liver. And if your muscles don't work well anymore, or your tissues deteriorate, we replace your hand and your arm. So he believes that there may come a time where we're going to be half biology and half computer.
Absolutely. I believe in that. Actually, like for me, I believe in personalized or individual treatments or therapy. And what I did during my PhD, we looked at RNA sequencing. So this is the base of the ones that
what I was saying.
Who was suggesting this?
Ray Kurzweil.
Okay. So he was suggesting that because we look at, the goal is to, for every single patient who have cancer, let's say who have cancer, okay, we can look at their RNA sequence. And look at with RNA sequencing, we look at to see what protein or what genes they become activated, and those genes, what's their function, what proteins they become activated, and what's their function, and how we can target that. So with combining the RNA sequencing and computational biology together, we can, as you said, one day achieve that goal of blocking all the pathways on all the proteins that can cause certain type of cancer.
Incredible.
And individual to individual is different.
Right.
Customized. Because it's customized.
That's
exactly.
Incredible.
Because cancer is very heterogeneous.
Yes.
So even though like one prostate cancer between two different patients, different mutations.
Completely different.
So we can customize it with, all those computational therapies in the future. I certainly believe we can do that.
It's so fascinating. I could talk about this for
hours me too.
More, because it's at the end of the day, right? What do we care about? It's living a long, healthy life, being with our loved ones.
Yes.
I, for one, would like to live very long, but very healthy. And I'd rather not be replaced by computer parts if I can help it. So I think I'm going to take a lot of the advice you've given today and try to apply it in my own life. I know I try already, but it would be great to live a long life that's also functional and healthy. That would be, I think, the goal.
That's a goal. That's the goal for everybody. And again, I strongly believe that we can increase our health span up to 100, 120 years age, living healthy.
That's amazing. That would be amazing. Well, thank you so much.
Thank you so much.
It has been incredible having you on. The knowledge you shared, this insight into this research that you did is incredible. I think you're in a field that has emerged as one of the most important fields that is developing in medicine and science. And it's going to become of greater and greater concern because, as you've said, the population is living longer and we need to live healthier, just in terms of not only personally, but also because of economics and being able to sustain this population. Yes. So I think it's an incredibly important topic. So thank you for sharing your expertise today.
Thank you for having me.
Absolutely. It's been a pleasure. My pleasure. And so I would love to thank her for Dr. Shelechi. We'll cut that out. So I'd like to thank Dr. Shelechi for being here with us today. And this is the last episode of this season. I want to thank everyone who has followed and listened, and I invite you to continue and look forward to 2026 and new episodes to come.
This is the Plastic Principle.